Starship Flight 13 is almost here, guys, and SpaceX has been moving at an absolutely incredible pace to get everything ready. Now, they're always known for working fast, but honestly, we haven't seen this kind of momentum in quite a while. And that's probably because this isn't just another routine test flight. On the surface, Flight 13 might look pretty similar to the last one. It'll launch, test a whole bunch of new hardware and software, and, if all goes according to plan, both stages will end their journey with controlled splashdowns. But look a little closer, and you'll find that SpaceX has quietly made some really interesting changes behind the scenes. Some of them could directly address the issues we saw on Flight 12, while others are all about making Starship just a little more reliable with every launch. So, what exactly has changed? Will these upgrades be enough to solve the problems from the previous flight? And just how close are we to seeing Flight 13 leave the pad? Well, let's find out. Now, before we get into what Flight 13 might do differently, take 2 seconds to hit that subscribe button. It won't make Starship launch any sooner, but it will make sure you're among the first to know when it does, or whenever something exciting happens in the world of spaceflight. Thanks, I really appreciate it. Alright, enough of the shameless plug, but seriously, let's rewind for a minute and look at why Flight 13 is actually such a big deal. You could skip this part if you wanted to, but I'd stick around. Taking a quick look at what Flight 12 got right and where it came up short does a great job of explaining what Flight 13 is actually trying to achieve and why some of these changes matter so much. Flight 12, which launched on May 22, 2026, was a pretty huge milestone. It was the very first version 3 Starship to fly, pairing Booster 19 with Ship 39. Right out of the gate, things looked promising. The vehicle lifted off cleanly from Pad 2, successfully pulled off hot staging, and climbed into space powered by the latest Raptor 3 engines. That's already a pretty respectable day at the office when you're launching the biggest rocket ever built. But, as usual, space had a few extra challenges waiting. During ascent, one of Ship 39's engines shut down unexpectedly. Starship is designed to handle an engine failure, so the mission kept going, but that engine out meant SpaceX couldn't perform the planned in-space Raptor relight later in the flight. Meanwhile, things weren't perfect on the booster either. The boost back burn, the maneuver that turns Super Heavy around for its trip back toward Earth, also ran into problems. Both stages still completed controlled splashdowns, but it was clear there were lessons to learn before trying anything more ambitious. As a result, the FAA required SpaceX to conduct a mishap investigation before Flight 13 could receive a launch license. It's standard procedure anytime something unexpected happens during a test flight. The goal is to make sure the company understands what went wrong, puts corrective actions in place, and shows that the same issues are unlikely to happen again. Because of what Flight 12 revealed, most people expect Flight 13 to stick with another high-energy suborbital mission instead of going for full orbit. And honestly, that makes a lot of sense. As exciting as an orbital flight would be, collecting reliable data is far more valuable than rushing to check another box. SpaceX still wants to verify engine reliability, refine the updated hot staging sequence, evaluate re-entry performance, and continue improving recovery operations before pushing the vehicle even further. It's like learning to ride a bike. Sure, you could immediately try riding down the biggest hill in town, but maybe make sure the wheels aren't falling off first. If all goes well, many expect the first truly orbital version 3 mission, and possibly even the first attempt to catch a returning ship with the launch tower, to happen on Flight 14. That lines up pretty well with what Elon Musk has hinted at before. He previously said the first ship catch would likely happen sometime between Flights 13 and 15, depending on how quickly version 3 proves itself. So the stakes are definitely higher this time around. Flight 13 isn't just another test flight. It's the mission that needs to convince everyone, including SpaceX, that the biggest problems uncovered during Flight 12 have been solved. If it can do that, the company can finally stop looking over its shoulder and start focusing on the next major milestone: sending Starship into orbit consistently, bringing it back safely, and eventually catching both stages right back at the launch site. And now, we finally know when it might happen. A new FAA advisory has listed Starship Flight 13 as NET Tuesday, July 14th, giving us the clearest indication yet that SpaceX is aiming for a mid-July launch. Of course, it's still just a target date, so there's always a chance it could slip by a day or two, which is pretty normal for Starship campaigns. Honestly, the timing caught a lot of people by surprise, myself included. Before the advisory came out, most of us were expecting Flight 13 sometime in late July, or even early August. So if SpaceX really does launch in mid-July, it'll be one of the fastest turnarounds between Starship flights we've seen so far. Then again, it makes perfect sense when you look at how quickly SpaceX has been moving lately. Just take Ship 40. the second Block 3 Starship upper stage prototype, which is currently back inside Mega Bay 2 after wrapping up the final stages of its testing campaign. And it's definitely been keeping busy. Unlike the rest of us, who celebrate surviving Monday with a cup of coffee, rockets have to prove they're ready before anyone lets them leave the launch pad. Ship 40 first rolled out to Massey's test site and completed a single-engine static fire on June 25th before returning to Mega Bay 2 the following day. But that was really just the warm-up. Then, on July 1st, Ship 40 rolled back out to Massey's once again for a full 6-engine static fire that lasted about 60 seconds. All 6 Raptor engines roared to life, stayed lit for roughly as long as they'd need to during the first minute of an actual launch, and gave engineers a mountain of performance data before the vehicle rolled back to Mega Bay 2 the very next day. That's a pretty significant milestone. It doesn't magically guarantee that everything will go perfectly. Spaceflight has a long history of humbling even the most confident engineers, but it does eliminate one major question mark. At least on the ground, Ship 40 seems to be performing exactly as intended. But as reassuring as Ship 40's successful static fire was, it wasn't actually the most interesting part. Some eagle-eyed observers noticed something unusual during the 60-second test, a small detail that could be hinting at a change for one of the trickiest moments in the entire mission: hot staging. If you're not familiar with hot staging, it's exactly as dramatic as it sounds. Upper stage ignites its engines while it's still attached to the booster. Only after those engines are producing thrust does the booster separate, begin its flip, and start its boost back burn. It sounds slightly terrifying, and honestly, it kind of is. But the advantage is that the rocket never completely loses thrust, squeezing a little more performance out of every launch. Now here's where things get interesting. During Flight 12, the plan was to ignite 3 vacuum Raptors and 1 sea-level Raptor almost immediately during stage separation. 4 engines coming online right from the start. But Ship 40's recent static fire suggests Flight 13 may be doing things a little differently. Instead of firing 4 engines straight away, it appears SpaceX will first ignite just 2 vacuum Raptors and 1 sea-level Raptor. Only after those 3 engines are up and running do the remaining 3 Raptors come online, bringing the ship up to full 6-engine thrust. At first glance, that might sound like a tiny software tweak. In reality, it could make a surprisingly big difference. Remember, when those first engines ignite, the ship is still attached to the booster. They're not just pushing Starship upward, they're also influencing how the booster begins its flip after separation. Think of it like pushing a shopping cart. Push right through the middle and it rolls straight ahead. Push slightly from one side and it naturally starts turning. SpaceX appears to be doing something very similar here, using the timing and location of those first engine ignitions to gently nudge the booster into its ideal rotation before it fully separates. At the same time, lighting only 3 engines instead of 4 reduces the amount of thrust acting on the 2 vehicles during those critical first moments. Less thrust means lower mechanical loads, which generally makes for a smoother, more controlled staging event. And this is also a very cost-effective solution. Instead of immediately redesigning hardware, they're asking, can software fix this first? Why build stronger structures if changing the flight sequence gets you the same result? Ignite engines a fraction of a second earlier, light fewer Raptors initially, adjust the throttle profile, delay the booster's flip ever so slightly. None of those changes require welding new steel or building new parts. They're simply changes to how the vehicle flies. If software solves the problem, it's faster, cheaper, and a whole lot easier than rebuilding the rocket. Sometimes, making a rocket more reliable isn't about adding more power. It's about knowing exactly when to use a little less. We've actually kind of seen this before. During the very first integrated flight test, Starship's original stage separation method didn't work as planned. So, SpaceX completely changed the approach and introduced hot staging, which has now become standard. That's pretty much how the company operates. Test something, figure out what broke, tweak the design, or sometimes just the software, and come back with a better version on the next flight. Of course, none of this guarantees success. A static fire can only tell you so much because the ship is firmly bolted to a test stand. During an actual launch, it'll be screaming through the atmosphere at several thousand kilometers per hour while separating from the booster, flipping, and dealing with enormous aerodynamic forces all at once. So while the new ignition sequence certainly looks promising, the real test won't come until Flight 13 leaves the pad. If you're as excited as I am to see this new hot staging sequence in action, let me know by dropping a "Let's go Flight 13" in the comments below. Meanwhile, Booster 20 is getting ready for its own shot at history. So far, things have been looking pretty solid. On June 5th, Booster 20 successfully completed an ambient gas pressure test, followed by a full cryogenic proof test on June 6th, where both of its massive propellant tanks were filled with super cold liquid propellants. A day later, it went through another cryogenic test with a partial tank load, once again checking that everything behaved exactly as expected. With those milestones complete, the biggest test is still ahead: a static fire at the launch pad. If SpaceX follows the same playbook as previous Super Heavy boosters, we can expect a full, or at least very high engine count, static fire, potentially lighting all 33 Raptor engines at once. Assuming that goes well, Booster 20's next stop will be the launch mount, where it'll finally be stacked with Ship 40 ahead of Flight 13. Unlike Ship 40, which grabbed plenty of attention thanks to its engine tests and a few interesting changes to its hot staging sequence, Booster 20 has been a much quieter story. There haven't been any obvious new features stealing the spotlight. Instead, it represents a steady evolution of the Block 3 design, carrying upgraded Raptor 3 engines along with structural refinements based on everything SpaceX learned from Flight 12, especially improvements aimed at propellant management and the boost back burn after Booster 19's less-than-perfect return. So while Ship 40 has been getting most of the headlines, Booster 20 still has one chance to steal the show. And if all 33 Raptors light up during its static fire, it'll be one of the most spectacular milestones we'll see before Flight 13. So, with both vehicles making steady progress, the pieces are finally starting to come together. If everything stays on schedule, here's what a fairly realistic Flight 13 launch day could look like. A few days before liftoff, Ship 40 and Booster 20 would finally be stacked together inside Starbase before making the slow trip out to Orbital Launch Pad 2. It's quite a sight to watch: 136 meters of stainless steel slowly rolling toward the pad, looking less like a rocket and more like a skyscraper that somehow decided to go for a walk. Once at the pad, the teams shift their focus to final checkouts. They'll verify the ground systems, run through propellant loading procedures, make sure the range is clear, keep an eye on the weather, and, of course, ensure the FAA launch license is active. Assuming everything checks out, SpaceX will target a launch window, most likely sometime in the late afternoon or evening. Of course, this is rocket science, so delays and scrubs are always a possibility. The weather might disagree, a sensor might decide today's the day to throw a tantrum, or the rocket might simply ask for a little more time. On launch day itself, road closures around Starbase begin several hours before liftoff as teams secure the area and prepare the vehicle. The launch tower's access arms retract, the ground systems come alive, and both liquid methane and liquid oxygen begin flowing into the rocket. During the final couple of minutes, the Raptor engines are chilled down to prepare them for ignition, and with about 10 seconds left, control is handed almost entirely over to the onboard computers. Then comes the fun part. At T0, all 33 Raptor 3 engines on Booster 20 roar to life, sending more than 7,000 tons of thrust into the launch mount before Starship slowly climbs away from the pad. About 2.5 minutes later comes the moment everyone will be watching: hot staging. Ship 40 ignites its engines while it's still attached to the booster before the two vehicles separate. If SpaceX's updated ignition sequence works as expected, it should make this one of the smoothest stage separations the program has seen so far. From there, Booster 20 will perform its boost back burn, followed by an entry burn and a controlled splashdown in the Gulf. A tower catch isn't expected on this mission, so the booster's goal is simply to demonstrate a cleaner, more reliable return than Flight 12. Meanwhile, Ship 40 will continue towards space. Depending on the final flight plan, it could deploy Starlink simulator payloads, attempt another in-space Raptor relight, gather more heat shield data during re-entry, and perform its landing flip before ending the mission with a controlled splashdown in the Indian Ocean. From liftoff to splashdown, the entire mission is expected to last somewhere between 1 and 1.5 hours. Neither vehicle will be recovered afterward. That's all part of the plan. For now, the objective isn't bringing the hardware home. It's bringing home as much data as possible, so the next Starship can fly even better.